Hi everyone, myself I am Hemant Gowda, BN Department of Civil Engineering. My technical seminar presentation on carbon nanotubes in civil engineering. Contents: introduction, objectives, literature review, type of carbon nanotubes, synthesis of carbon nanotubes, properties of carbon nanotubes, application of carbon nanotubes, uses and applications, conclusion, reference. An introduction. Carbon nanotubes are being used in civil engineering for their unique properties such as high strength, stiffness and durability. They are used in various applications such as concrete reinforcement, soil stabilization and bridge construction. The potential use of carbon nanotubes has been explored in this article. The element SWT is visible in layers of the cylinder, just like the name itself that represents tube form. The fundamental and applied civil materials engineering use enhanced chemical with unique properties determined by their composition, chemical bonds, size and morphology. The cylinder carbon molecules feature high aspect ratio, length to diameter values typically above 10-3 with diameters from about 1 nanometer up to tenths of nanometer and length up to millimeters. Carbon nanotubes are also called bucket tube, nanoscale alloy tubes composed of carbon atoms. Objectives: CNT can improve the high temperature resistance of cement-based material. One study explored the influence of CNT reinforced cement-based material at high temperatures and found that the addition of CNT improved strength more than in ordinary concrete. Carbon nanotube is a promising nanomaterial with excellent mechanical, electrical, thermal and chemical stability. It has received extensive attention due to its unique multifunctional properties in engineering materials. Research have explored the preparation and characterization of carbon nanotube reinforced cement-based material. Studies have shown that adding CNT will significantly improve the performance of cement-based material. And this literature review, where title, author, year, pros and cons. Carbon nanotubes are the first title and the author is Rajwat Kaur. It has published on 2018. Its advantages are chemical vapor deposition is best methods for production of carbon nanotubes. The aim of this paper is not only to lay stress on its unique properties but also its harmful effects that can occur during the use of metals that are very toxic. And its negative is it is difficult to target large amount of graphite in industrial process. It is difficult to maintain high quality and lower impurities. And next, carbon nanotube based nanocomposites and their applications. The author is Bullet Ecker, Asugyal Agdon and Ecker Maurat ads. It was published in the year of 2017 and the pros is small volume and consequently lighter weight, resistant to temperature changes. And the negative are there are specific disadvantages such as manipulation of this material due to their small sizes. And the next is a review on the synthesis properties and utilization of functionized carbon nanoparticles for polymer nanocomposites. And the author is John Van Lim, So Tun B, Lee Tinsin, Chantar V. Ratnam and others. The author, it was published on 2021 and the pros are some important traits such as lightweight, small in size, good strength and high conductivity. CNTs have initiable kind of properties like mechanical, electrical and optical. And the pros cons are for commercial applications quantities of purified nanotubes are needed. And the next is developments and applications of carbon nanotubes, reinforced cement based composites as functional building materials. And the authors are Kai Chu, Jan Chang, Lucio Fio, Chok Lancho and Denvid La. It was published on 2022. And the pros are using CNT in 3D-PC can effectively reduce the setting time of 3D-PC and improve production efficiency. It can reduce drying shrinkage of 3D-PC, improve printing quality and improve the early strength of 3D-PC. And the negative are at the rate our technology has been becoming absolute, it may be a gamble to bet on the technology. And the next, the types of carbon nanotubes, where types of carbon tubes are, there are two types. First one is single walled carbon nanotubes and the second one is multi walled carbon nanotubes, where the single walled carbon nanotubes, it is represented as SWCNT. The single walled carbon nanotubes exists in a 1D structure, where some examples of single walled CNT are armchair and zigzag single walled carbon nanotubes, where multi-walled carbon nanotubes, it is represented as MWCNT. It is composed of several nested carbon nanotubes. This type of nanotubes are as two diameters. One is known as outer diameter and another is known as inner diameter. An example of multi-walled carbon nanotube is chiral multi-walled carbon nanotubes. The properties of single-walled carbon nanotubes are: the diameter of single-walled carbon nanotube is 2 mm. The length of single-walled carbon nanotubes is around 2 micrometers. They exist in a one-dimensional structure, therefore it is known as a nanowire. Electronic can be miniaturized by using a single-walled carbon nanotubes. Their band gap varies from 0 to 2 electron volts. They show conductivity like a semiconductor, therefore they exhibit both metallic and semiconductivity behavior. Properties of multi-walled carbon nanotubes are given below. The outer diameter of multi-walled carbon nanotube is around 2 to 20 nanometers. The inner diameter of multi-walled carbon nanotubes is 1 to 3 nanometers. The length of multi-walled carbon nanotube is around 5 to 6 micrometers. And the synthesis of carbon nanotubes are: the technique have been developed to produce carbon nanotube in sizable quantities, including arc discharge, laser ablation, high pressure and carbon monoxide disproportionation and chemical vapor deposition (CVD), where most of these processes take place in a vacuum or with process gases. CVD growth of CNTs can occur in vacuum or at atmospheric pressure. The large quantities of nanotubes can be synthesized by this method. Advances in catalysis and continuous growth are making CNTs more commercially viable, and the CNTs are synthesized by thermal CVD method by using carbon gas as carbon sources. In this method, a quartz tube is placed inside a furnace maintained at the high temperature 500 to 900 degrees Celsius, heated by RF heater. And this is the process of synthesis of carbon nanotubes, or synthesis of carbon nanotubes, which distinguishes by carbon arc discharge, laser vaporization or ablation technique, catalytic chemical vapor deposition, high pressure conversion, COMOCAT, and this all frame a structure called substrate reactic and floating reaction. And carbon nanotubes properties, where carbon nanotubes are the type of carbon with a diameter of nanometers and a length of carbon micrometers, where the length of diameter ratio exceeds 1000. CNT is made up of enrolled cylindrical graphite sheets named graphene, wrapped up into a seamless cylinder with a nanometer sized diameter, where it has distinguished between four types, where the first one is electrical conductivity. Carbon nanotubes are electrically and thermally conductive and have a high mechanical strength. Parallel arrays of multi-walled carbon nanotubes can be drawn into electrically conductive continuous length webs. Strength and elasticity. In terms of tensile strength and elastic modulus, carbon nanotubes are the strongest and stiffest material yet found. Thermal conductivity and expansion. The carbon bond's rigidity aids in the transmission of vibration throughout the nanotube. resulting in excellent heat conductivity because each carbon atom is conducted to the three other carbon atoms by strong covalent bonds. Carbon nanotubes have a extremely high melting point. This also leaves a spare electron on each carbon atom, resulting in a sea of delocalized electrons with the tube, allowing nanotubes to conduct electricity. And the last is electron emission. Because each carbon atom is connected to three other carbon atoms by strong covalent bonds. Carbon nanotubes have an extremely high melting point. This also means that each carbon atom has an extra electron, forming a sea of delocalized electrons within the tube, allowing nanotubes to conduct electricity. Carbon nanotubes properties basically are thermal conductivity, electrical conductivity, and it also depends on aspect ratio. And CNT are very elastic, 18% elongation to failure. CNT have very high tensile strength, and it also have highly flexible, can be bent considerable without damages. CNTs can a low thermal expansion coefficient. And the applications of carbon nanotubes are: carbon nanotubes are unique properties that make them useful in civil engineering. They can be used to enhance the mechanical properties, durability, and specific applications of cement-based material. They can also be used in construction with the least and latest technology. For example, they can be used as a reinforcing material in concrete structures. Carbon nanotubes have a wide range of applications. They are used in energy storage, device modeling, automotive parts, boat hulls, sporting goods, water filters, thin film electronics, coating, actuators, and electromagnetic shields. They have also been implemented in nano-electromechanical systems, including mechanical memory elements and nanoscale electric motors. Carbon nanotubes uses and applications. Basically, carbon nanotubes are utilized in energy storage, device modeling, automotive parts, boat hulls, sporting goods, water filters, thin film electronics, coatings, actuators, and electromagnetic shield. Because of their large surface area, CNTs have been successfully used in pharmacy and medicine to absorb or conjugate a wide range of medicinal and diagnostic substances. Carbon nanotubes have a number of unique chemical, size, optical, electrical, and structural properties that make them appealing as drug delivery and biosensing platform for the treatment of a variety of diseases and non-invasive monitoring of blood levels and other chemical properties of the human body respectively. Carbon nanotubes have unique qualities such as high surface to volume ratios, increased conductivity and strength, biocompatibility, ease of functionalization, optical properties, and so on. And the conclusion is, the applications of CNT in the field of energy conversion and storage, environmental monitoring and wastewater treatment, as well as green nano composite design are research area of growing interest from their potential uses in future technologies point of view. This review examines the attributes of CNTs as the electrode material or conductive filler in the electrochemical devices of energy applications. The potential development of carbon nanotubes are sensing material in nanosensors for environmental monitoring in addition to the development as absorbents to remove pollutants in wastewater treatment are discussed. The advantages imparted by carbon nanotubes in green nanocomposite material and their impacts on the environment are explained in the last session. As reviewed, carbon nanotubes have demonstrated advantageous potentials in energy and environmental applications with their outstanding structural, electronic, and mechanical properties. Development of carbon nanotubes integrated energy conversion technologies implement with efficient energy storage system have shown promising progress in efforts to address the energy challenge for future clean and sustainable energy sources. And the next is references. Where references are carbon nanotubes, basically there are so many authors made a different experiments. For example, properties and applications where software covers, and the another one is synthesis properties and applications of carbon nanotubes, and nanotechnology and nanostructured materials trends in carbon nanotubes. And the another is carbon nanotube synthesis in flame using laser ablation for in situ catalyst generation, and the another one is single-walled and multi-walled carbon nanotube structure synthesis and application, and the last one is single-wall carbon nanotubes polymer solar cell, and the photovolts results appeal, and there are and the results are basically carbon nanotubes have a number of characteristics including high flexibility, good thermal conductivity, low density and chemical stability. Carbon nanotubes have played an important part in nanotechnology, semiconductors, optical and other branches of material engineering to the remarkable futures, where carbon nanotubes are rolling cylindrical structure. Multi-walled carbon nanotubes have shown improved electrical conductivity, large surface area, better chemical consistency and mechanical strength. And thank you.